Hello, everyone. I'm very excited and also extremely nervous to be here today. I'm happy to be the one to be presenting AMP Script, a way to incorporate custom JavaScript into your AMP documents. There are billions and billions and billions and billions and billions of AMP documents available across the web, and they share three key traits that I think are important and worth calling out. First, instant loading. When you're on an aggregator and you click on a hyperlink to an AMP document, it feels like it's already there. It renders almost instantly, and it's a magical feeling that's not expressed across the wider web. The reason for this is item 2, privacy-preserving preloading. So while you're sitting on the news aggregator looking for the content that you would like to click on, we can, in the background, load AMP documents and have them ready and available. So when you click, they're there just like that. Now, this doesn't work unless we build in the concepts of preserving privacy during those pre-renders all the way into the architectural core of the framework itself. If we preloaded a document and it exposed credentials about a person in advance, it could be used for targeting information. We think that this one piece is one of the reasons why AMP works so well. We make sure that privacy is preserved during that preloading process so that articles and other content appears instantly when you click on it. And third, believe it or not, is a reliance on JavaScript to improve user experience. Yes, that JavaScript. Now, that might seem a little strange, because so far we haven't allowed custom JavaScript within AMP documents. But here on the AMP team, we love JavaScript. It's the world's most popular programming language, and it's core to how the web works. Every single AMP component is authored using JavaScript, from AMP image to AMP story. But so far, we've restricted this JavaScript to the growing list of high-quality components. This can have unintended consequences over billions and billions of documents, leading to greater similarity and less customization unique to each domain. We'd like to allow developers like you to leverage some of your own JavaScript within those AMP documents without impacting user experience. We believe a little bit of JavaScript, and I mean a little bit, will allow your documents to express your intent more uniquely. Last year, you might recall that we presented this idea with a bunch of caveats. Here they were. We were very nervous about this project. We just started it when we spoke about it last year, and we had a lot to learn about whether it was possible. And over the course of the year of developing this technology, we learned a lot. We were scared often. We were nervous that we made a promise that we couldn't deliver on. Internally, this project became known as the Kraken. The Kraken is a legendary cephalopod that tormented early sailors traveling into the unknown territories. And this is kind of what it felt like to build this specific technology. When you're right at the edge between the known and the unknown, it's easy to start to imagine how hard it can be to make up mythical sea creatures that are making it impossible for you to achieve your goals. But we're really happy to say that we've tamed this Kraken. We've made it possible. We've worked with it very well, and we're ready to release the technology so you can fare across the seas safely. Let's talk briefly about how this specific technology works. In an AMP document, there are two main pieces to remember: the runtime and components themselves. The runtime is shipped normally as v0.js. And this specific runtime prevents the document from loading content that is too far away from the visual viewport. A great example is images. Say there's an image at the very end of a document that's 30 pages long. We will not load that image up front until the user gets close enough to where it would start to display. And we also give a little bit of buffer room in advance. This means that when you're visiting a document that has a lot of images, that you're not using your entire data plan up front, only when you go to interact with those pieces. But it's not just for loading images that we do this. We also use this for our JavaScript as well, ensuring that components that are far down the screen do not start up or perform computationally heavy tasks until they start to get closer to where the user has expressed intent to see them. Because we have this runtime in place, we can ensure that DOM reads and writes are batched. It's a well-known pattern, and all AMP components are considered efficient and the runtime prevents a number of potential issues. So what happens when we introduce custom JavaScript into this environment? It can't be managed by the AMP runtime. It's not possible. This component may load a number of assets before it's anywhere near the visual viewport, breaking some of our promises about how AMP documents work. Or even worse, it could consume a tremendous amount of CPU, doing something computationally expensive that is relevant to it. This one component could be the bad actor in a complex system, lowering overall performance and unintentionally giving users a poor experience. So how do we solve this? First, we put a sandbox around that custom JavaScript. It's both a security and a performance sandbox. And it prevents that specific JavaScript from abusing system resources in the main thread and also accessing parts of the document outside of its scope. That way, when you put an AMP script on the page, you can feel confident that it's not going to interfere with things outside of the AMP script root. Next, we put that specific context in a worker thread. So we transmit that JavaScript over and create a new worker from scratch. But the worker thread, like all web workers in JavaScript, does not have access to the document object model. This is an intended design decision. And as a result, JavaScript frameworks and your custom code do not operate in this context the same way that they would in the main thread. This is a pretty large problem. So we invented a library called WorkerDOM. WorkerDOM does exactly like what it says. It creates the DOM, a fake DOM, within the specific context of a worker, allowing you to use all of the DOM mutations and frameworks that use those specific instructions without much change. Then we put your custom JavaScript inside that container. But this also creates another problem. Now that worker thread has a whole set of changes it would like to express the DOM, and it's already done it. It said, I would like to append a node here and remove this one here, add an event handler to this one here and this one there. So we need to be able to transfer those commands back to the main thread and apply them. So let's walk through a simple example. Here we've got 2 lines of code. The first line, we're going to create an element, a div. And we're going to assign it to a representation that we call div. Afterwards, we're going to take that div element and append it to the document body. Now this is vanilla JS. However, your frameworks that you also use do these things under the hood. Let's talk about how we do the creation of elements for a second. This specific command, create element with the first argument of div, is what we're going to achieve with this numerical sequence. This is an array buffer of uint16 values. The first value, 3, is the persistent reference to this node. When this node is created, it's assigned that identifier and is transmitted between both threads. So now if the worker or the main thread refers to node 3, both of them know what they're talking about. The second node, our second number, tells the main thread what type of DOM node should be created. Because this specific instruction said create element, we're going to use the number 1 here. Now, this is not a made-up number. The node prototype includes all of the types of nodes you can create. One just happens to be node.elementNode. The next value is something that we couldn't know in advance, the string div. OK, maybe we could have known about div, but not the text that's in arbitrary nodes. So what we do here is we create a string pool. Every time we encounter a new string, we put it into the string pool, and now we have a persistent reference to that specific string. We can use that value on both sides of the bridge, and we can get a resulting value from a numerical index. The fourth value is what text would be contained inside of this node. Now, this example is create element, so the text that is inside this node is 0. 0 is a magical constant, and it effectively means that there is no content inside of it. However, as a thought exercise, if this was create text node with a first argument of foo, then what we would need to do is transmit the index value of that foo string inside of this specific reference. The final value in create element is the namespace of the node. So by default, elements created through createElement have an HTML namespace. However, if you were creating something like an SVG, you would use createElement.ns, and you would specify two arguments. The first, tag name. The second, the current namespace for that node. So we would need to transmit that namespace as the value here from the string pool. Now we're on to appending that child to the document body. So how do we do that? Again, we're going to rely on an array buffer to transmit this information. Here we've got the number 2 to begin with. And this number represents the type of operation we're going to be performing. 2 indicates appending a child. The next value is the identifier for the parent that we're appending to. Document.body has that unique identifier that was assigned up front of the number 2. The third value in this buffer represents the next sibling node. So if you were referring to that next sibling node when you appended this object, we would need to transmit its identifier here to correctly insert the node in the right place in the DOM of the main thread. Same thing goes for previous sibling. If you would have referenced the previous sibling here, we need to transmit it as well. Now here's where things get a little different. The next item is the number of nodes we intend to append to the DOM. But why would we ever need this value to be more than 1? You can't append more than 1 node at a time through this API. Well, really, this specific construct is a DOM change list. And what that means is the ability to append and remove multiple children at the same time. So while there may not be a DOM API for that today, this interface would allow us to support future DOM APIs that may allow that in the future. The next value is the number of nodes that we intend to remove. So this structure can be used both for appending and removing nodes. And the final value is a spread of the items that we intend to add with their unique identifiers, followed by the items that we intend to remove. Congratulations, we successfully requested a node to be appended to the document body. And for reference, here are those 2 array buffer sequences again. Creation of a node, and leveraging that node as we append it to the document body. This allows worker DOM to send messages quickly and efficiently between threads and apply DOM mutations. So let's build something. That was a little deep. Maybe we can back up and build something and make this a bit more fun. Let's start with the Kraken document. This is an example that I built, and it expresses most of the common functionality that you would need to do within an AMP script component. We start with a valid AMP document. I've omitted a ton of the AMP document code here to try to bring this example down and simplify it a bit. But really what we're doing first is we're appending a new script tag. That script tag is for the custom element AMP script. Later, we leverage the AMP script custom element itself, and we pass into it an attribute that is the URL of the JavaScript that will enhance the DOM nodes inside of it. And again, we have children inside of it here, a single child that's a div. When the worker starts up, it will have knowledge of this div. It's already there. So frameworks that are more like jQuery type plugins will work successfully. Next, we need to write some JavaScript. That JavaScript will interact with a DOM inside of the AMP script element and treat the root of the AMP script element as the document body. So each AMP script element that you create is a new document and a new document body. This example is using Preact. And all we're doing is creating a div node in our component method. That div node, inside of it, has a class attribute with the name fill. It's the same thing that you saw on the previous slide. When we go to render that specific element to the screen, the component is put in document.body. Now, the third argument here is specific to Preact. What it means is it will merge what was existing in the document before with what you've now specified. Next step, we need to make sure that our server is responding with the correct set of headers. So this is one of the security constraints. Here, AMP access control allow source origin, say that 3 times fast, will allow you to specify what origins are able to modify, are allowed to load JavaScript from. So if you have an AMP document and you load JavaScript, that JavaScript resource needs to make sure this header is present. Now, I've hard-coded the values in this example, but you should figure out what's best for your serving environment. We're likely better off calling what we just created not the Kraken document, but really the empty document, because that's all that was in it. So let's add some interactions. The first thing we're going to do here is insert a logo component. When we do that, we import the component, and then we leverage the logo component within the render method. So now this div is going to have a single child that is the logo component. Here is the logo component itself. So an important thing to note here, I've used a component called amp image. Now that is just something that I wrote that actually outputs an amp-image. And the content of that is the attributes that you would apply to an amp image. However, it's important to note that we've added a click event listener to that. So now every time the amp image is clicked, we're going to run the method handleClick. When handleClick is called, we're going to change the state of this Preact component, and it will toggle between the animation. So we'll be able to say, animate this component when you click on it, and when you click again, turn off the animation. We need to wire that up to some CSS. So here's the CSS for this example. I have an animate class name, and when it's applied, it uses a CSS animation to wobble the logo back and forth. Now we've gone from the Kraken document to the wobbling document. Maybe we should go a bit further. Now, for the sake of time, I'm going to just jump to the end here and show the example and talk through it a bit. Here we've got the click that causes the logo to wobble, and there's a giant Kraken at the bottom. When I click on that, a series of SVG images will start to fall from the top of the screen. Now, these SVGs are randomly placed and go in random directions. So if I click on it again, you'll see a different sequence, and they go in different patterns. Lastly, I added a touch move event listener onto the document body, which will allow us to see the cursor and the lag time for sending events back and forth between threads. Pretty quick. You can achieve a lot of what you want to do in your custom components using just these pieces. So what's supported? Well, quite a bit is supported, but not everything. We have a handy-dandy chart right here that you can go read, and I recommend taking a look at that if you plan to use AMP script. It will tell you the DOM APIs that are supported and what is not supported, and also what is coming soon. An important note to add as well is that we've built a linter that will analyze your JavaScript code and look for patterns that will work or need replacements and give you hints. Let's talk about the trade-offs and restrictions for a second. Because like all things in computer science, nothing is perfect. You have to make trade-offs in order to keep moving forward. There's a few that I'd like to call out that are important to know as you start to use AMP script. The first one is 150 kilobytes. That is the maximum size for all JavaScript content on an AMP document. No more than 150 kilobytes, no matter how many AMP script elements you put on a page. And this size is not based off of the compressed size. It's based off of the decompressed size of your JavaScript. It's not a tremendous amount of room, but we think it's plenty to accomplish a ton. So why 150? Well, first off, we're being a bit conservative up front. If we find that this rule is too restrictive through testing, we will be able to loosen it. But that's only if we are absolutely certain it will not impact performance on low-end devices. The second, the internet in general is awash with JavaScript. As an industry, we choose this particular tool more frequently than we should. The impact of JavaScript is far greater byte for byte than any other resource type on the web. And left unchecked, the size of scripts will have an adverse impact on the loading performance of AMP script document segments. We're also concerned about parse and evaluation time of this JavaScript. And we want to make sure that those low-end devices continue to have a great experience using AMP. Next number is 0. This is the number of mutations that an AMP script is allowed to make without user interaction. The idea here is Just like in AMP, things will not change unless you as a user click or interact with the document. If this rule is violated in custom JavaScript, if there's an attempt to mutate the document without a user interaction, the JavaScript is shut down and destroyed. The AMP script is left inert in the last state that it was. The intention here is to make sure that AMP script doesn't do things that are unexpected. There is an asterisk, though, and it's an important one. If you have a statically sized object on screen that's an AMP script, and it's below a certain height, we will allow it to mutate as much as it would like to. The reason for this is that it's perfect for things that use WebSocket connections to update status. We think this is a large use case that's not addressed today within the AMP ecosystem, and we like to make sure that it works correctly. Next number, 5 seconds. This is how long custom JavaScript is allowed to make mutations after an event has been registered and fired. The reason for this is that we don't want users to have a long wait between their click and the actual change being seen on screen. If you violate this rule again, what happens is the AMP script component is shut down and left in the last state that it was. Again, there is an asterisk. And this one's a fun one. Sometimes when you get a click event, you need to ask the server what to do next. So we recognize that case. And what we do is when a fetch is initiated within this timeline, we will extend the duration of the allowed mutations until the first bytes of that fetch come back, plus 5 seconds. So if you need to fetch something from an event, go ahead. It will work just fine straight out of the box. The next item is asynchronous computed layout. Now, typically when this term is used, it's called synchronous computed layout. But because this is running in a worker, it's all asynchronous. So what does that mean? Often in JavaScript, you need to know the client rect of an element, its current position, its size, so you can do some calculations to understand what to do with it. In this case, our div is going to ask for its client rect by using the method getBoundingClientRect. This method doesn't exist in AMP script at all. And here's why. When we're in the main thread and we have a div like this that needs to know its client rect, it asks the browser directly. Now, that information isn't always available right off the bat. Sometimes the browser must relay out the element to get that data, but it's available very quickly. And as a result, JavaScript code can be pretty much halted and held onto until that value comes back. This is a little bit different when we're in a worker environment. Now we've got the div element inside the worker, and so we're going to request the client rect. When we do that, in order to get the data, we don't know that information in the worker. We don't have access to computed layout. So we need to send a request across the bridge for that information to the div on the main thread. It will find out its layout synchronously, and then afterwards communicate it back to our worker and back to the div element. This can take time. It doesn't take much time, but it can. And as a result, we would like to make sure that programs are not reliant on synchronous behavior. So instead of using div.getBoundingClientRect, you just need to change this slightly. Just put in a wait before and ask for the getBoundingClientRect async. GetBoundingClientRect async returns a promise with the client rect. So the moment that promise resolves, you have the same data that you would have had synchronously. Well, that was fun. Let's get into something a bit more practical. Let's start with frameworks. We've worked really hard to make sure that Worker DOM is a DOM implementation that's not specific to our needs. And as a result, AMP script can support many popular frameworks. We know that these three in particular, Preact, React, and Vue, work pretty well out of the box. And we're working with framework authors to make sure that we're not doing things within AMP script that would break their code. Here's an example. On the left, we have, this is to-do MVC implemented in both Vue and Preact. And as you can see, things work as you'd expect. However, all of the custom JavaScript for these experiences is running within the worker. And it just works. It's pretty cool. Next, we partnered with our friends at the Washington Post. The Washington Post does an amazing number of interactive articles with charts that you can click on and data graphs and all sorts of things that were difficult to achieve in AMP documents beforehand. So we ported one of the more recent articles. Has a bunch of SVG charts, and you can interact with those charts and change the DOM through those interactions. You can also go up to this top selector and change the year that you were born. And when you do that, it will change all of the charts across the entire page. Underneath this chart, as you select, the text values are changing to represent data points that are collected. There's also a video embedded within the page. And when you watch that video, you can use the controls as you would expect. This is a perfect representation of what we think AmpScript is great for. It's something that can take documents that were 95% of the way there and get them the final 5%. E-commerce is also a very important part of the web. Many checkout flows on AMP documents are not built using AMP. And we wanted to see if it was possible to implement a checkout flow using AMP on a document. Philip Stanis, a member of the AMP team, worked on this specific demo. Here, we have an inline multi-step checkout flow. So just pretend for a second that we clicked on something to buy before this started. This would pop up and allow you to actually complete the information and send something to Testy Testerson. And we would be able to complete the entire flow. You can go through, add all the information of your address, the name on your card, your CVV, all the kind of things that you would expect a checkout flow to need. And this is all running in a valid AMP document. No longer do you have to leave an AMP document to actually achieve these kind of interactions. When I hit verify here, the next thing that will happen, confirm here, the next thing that will happen is you'll see successful confirmation of the purchase. The next thing is talking about how the web used to be. So I really loved GeoCities. I thought it was amazing, and I kind of wish it would come back in a way. And so we have a person on the team named Alan who also feels the same way. And he built a demo that's called bling.cool. And this is a conversion of that specific demo to run in AmpScript. Now, the interesting thing about this demo is not just that it looks pretty cool, but that it's the same code base that runs in the non-AMP version and the AMP version. Both are the same, which means he can ship just an AMP-first representation. How fast is this? Right? We're sending messages back and forth between threads. There's a lot of computation going on. It looks like a lot of work, right? It can't be efficient. Well, transferables and array buffers are very efficient, and they're only getting better with continued investment from teams like V8. Here's an example of a popular benchmark called dbmon. And what this does is it flushes a ton of DOM writes as fast as it possibly can to screen. This implementation is running inside of AmpScript and has a very steady 60 frames per second. It works very well, and the main thread is using a very small amount of memory. How far could we go? So talked about how fast. We talked about what you could use it for. We've seen lots of really interesting examples that are quite practical and kind of fun. We wanted to see how far it could go to. How far could we push the limits of this technology? So Aaron from the AMP team built an emulator. This emulator runs in AmpScript off of the main thread and works. It's playable. It works as you would expect. And it's actually fairly small. Now, this example is not small enough to go on an AMP document. This is invalid AMP to do this. And we think this is beyond the limits of what you'd want to do on an AMP document. But it does demonstrate that the technology is capable of doing far, far more than what we thought initially. So when is this going to be available? It's a lot of work. It's very interesting. Well, Malta talked about this earlier, but it's available today. You can try it out now. And I'm very excited to hear your feedback. I think you're probably going to run into things that need to be fixed or need to be addressed. And as a result, we're opening it up today as an origin trial. So you can go to this URL and register yourself for your domain, and we will send you an origin trial token. This will allow you to put AmpScript components on pages and try it out. But we really want your feedback. We want to hear what's difficult. We want to hear what's hard. We want to hear what works and what doesn't. And we're looking forward to hearing from you as you try it out. I'm very excited to have been here to talk about AmpScript. Thank you so much for having me.